Good afternoon everyone, myself Laksh. So today our mini project topic, that is the APMS, the Automated Pipeline Monitoring System. So in this, why I chosen this project, because of its real life application. The project is directly applicable in industries in prevention of the hazardous events that can take place, the hazardous disasters and the dangerous disasters that can take place. So why did this project, why its importance and other factors influenced us in making this mini project? So first of all, we all know that industries are growing at an exponential rate. We all know that industries are growing like very fast, and many other preventive measures should also be taken in running of the industries. We all know that the government had laid down certain principles, certain parameters for the industries to avoid life and threat. So the main concept of this mini project is it controls, especially it is mostly applicable in chemical and petrochemical industries, in the industries where the elements are used are quite dangerous. So in this project, we will limit the things. In this, the level of the certain level are there in the industries in which as the level increases, that things can be dangerous. It should be controlled in a proper manner. So our mini project provides a barrier at a certain level where the increase automatically stops. So thus preventing many incidents, and thus the many advantages that can take place in the many prevention of the material can also take place, leading to less wastage of chemicals, leading to less wastage of the effluents in the industrial environment, and many other things. And we all know that we are the engineers. We all know how our mind are designed to innovate new things and new solutions. So that's why we have made this, and proper pipeline. It gives us the proper pipeline system, proper system, and other many advancements can be made in this project, and this will purely help in the future. Thank you.
So I'm Rishit Pawar, and I'm going to explain how the pressure sensor works and how the circuitry of the pressure sensor. So this is the pipe. There are two pipes. This is the inlet from which the air is going to flow. This is the one pipe where pressure sensor is connected. This is the second pipe where the solenoid valve is connected. So basically this is turned off, and this is acting as a blockage for now. When the air will start flowing from this pipe, the pressure in this pipe will start increasing. So in order to decrease the pressure, the solenoid valve will open up, and the air will start also flowing from this side. So how the overall circuitry is, this is the Arduino board, and this is the distributor. So basically when the pressure sensor gives a signal to the Arduino board gives a signal to the distributor to distribute the energy which it is getting from the LiPo battery. It is a 12-volt LiPo battery. Now this distributor starts distributing the energy and gives it to the relay module. So this is the relay module, and how it works is basically there is a switch type. It acts as a switch. So when it is turned on, the switch acts in a way such that the 5-volt which is getting from the Arduino board as well as the 12-volt which it is getting from the battery, it combines and it gives it to the solenoid valve, and this opens up. So this is how the pressure sensor works and the overall circuitry of this pressure sensor.
Hello, my name is Brandon Kulaso. So I'm going to explain to you the code and the working of how this whole circuit works on Arduino. Okay. So we start off this code by initializing the first sensor, which is the pressure sensor. So this is on analog A0. Then we take a variable for the sensor to get the sensor readings, and then we have another variable with a constant value, that is the conversion factor. We use this conversion factor to convert the sensor readings into actual usable readings into force and newtons. Then we have a solenoid pin, that is to operate the solenoid we initialize one of the pins, digital output pins to it. Now in void setup, we have serial.begin, which initializes the bud rate of 96,000 bits per second. Following that, we have pin mode to select the solenoid pin and also use it as an output pin. Then digital write, this line is used to set the solenoid at a closed state. Now in the main body of the of the code, we have loop which keeps on running. Now, firstly, we use this sensor to get the analog readings from the sensor that we have connected. Now, these readings are not usable, so we convert them into force by multiplying it with a conversion factor of 0.01. After that, we print the sensor readings as well as the force readings that we get. And this is the main logic for how this solenoid valve opens. If the force drops and is less than 1, then this code will set the solenoid pin on high, that is, open the valve and let the pressure release. Otherwise, it will keep it at a closed state. And then we have a delay to repeat this loop again. Okay, so we have an Arduino board that is connected through jumper cables to a temperature sensor. The first pin is connected to the analog pin of the Arduino board A0, and the other two pins are connected to ground and VCC respectively. Now, as the gas passes through the first pipe, the temperature increases. As a result, the temperature sensor detects that, and you will get the output of the temperature sensor on the serial monitor.
Hello, Rishit back again, and I'm going to explain the code of the temperature sensor. So here we have initialized the LM35 pin, that is the temperature sensor, to the digital pin A0. Next we in the void setup, that is which will run only once. Here it is we have started a serial dot begin, that is the serial communication port for a 9600 baud value. Then in the loop function, we have set the we have initialized a variable called analog value, which will read the temperature, which will read the input from the LM35 pin, that is the A0 pin. Now that is the voltage reading, so it has to be converted into something which is measurable. So here we have defined float temperature, and we have multiplied the analog value with a conversion factor, that is multiplied by 5 into 100 divided by 1024. So basically this 5 is the 5 volt that the Arduino is providing, and 1024 is the range of voltage. And afterwards we are printing the temperature value, that is serial.print in temperature in degrees Celsius, and serial.print ln, that is obviously degree Celsius. And then we have applied a delay of 1000 to repeat the code. Thank you.
Hello, my name is Kevin. Let's conclude the project. APMS, Automated Pipeline Monitoring System. Our project basically can be applicable in a very cost-effective way in various industries, mainly the chemical industries. Our project mainly speaks about the pressure control and the temperature control. If a pressure exceeds to a certain value, almost about a safe value, then it shows some precautionary measures. Same goes with the temperature. As it is exceeding the safety value or decreasing the safety value, that can harm the products which are constructed in the chemical industries, it can cause the prevention. The main motive of our project is to provide safety and help the industries to inbuild these products in a very low and effective cost. Thank you.